Hey, welcome back. I just want to mention before I start, I always try to put little video quiz things in my lectures, and I'll definitely remind you in my intro video, which I haven't done yet, weirdly enough. But yeah, it's just to make sure that you're watching the videos. So I'll say this is the video quiz, and you basically can just copy down that particular problem, and then you're basically putting maybe like 4 at a time onto a piece of paper. Then you're taking a picture of it or scanning it, uploading it to your computer, turn it into a PDF, and then send it to my email. I think I'm calling them video quizzes. They're not really quizzes though. They're just, did you watch the video kind of thing. So just be aware. I forgot to put it in my first video, 11.1. But if you look at the comment, it's actually example 7 would be the video quiz. So that would be the first problem in your submission for the video quizzes. So I apologize for that ahead of time. So I do forget because it's not something I care that deeply about, but I need to make sure you're watching these videos. Anyways, again, 11.1, it was example 7, and it's at 3540 in the video. So there's that. I think that's all I wanted to say, hopefully. Okay, so anyways, today we're going to be looking at space, basically three-dimensional coordinate system. You see a nice little picture here in the book. So now these planes kind of, instead of having 4 quadrants, now we have 8 quadrants. They actually have a special numbering. I have literally never used that numbering system except in some of the other homework softwares and make a big deal out of it for some reason. But yeah. So anyways, let's introduce the coordinate system here in space. And what we'll have are 3 axes now. So this is the z-axis. This here is the y-axis, and then coming out of the page, so to speak, at you is the x-axis. So in this direction, the positive x-axis. In this direction, so this direction is positive x-axis. This direction is positive y-axis. Going up is the positive z-axis. Okay, maybe put little tick marks on there. 1, 2, 3, -1, -2, -3. I sort of missed there. 1, 2, 3, 1, -1, -2, -3, 1, 2, 3, 1, 2, 3, just like that. Okay. Plotting stuff and drawing stuff in space is a little more difficult, as you might imagine. Let's try to plot a couple points here. So the first one, we'll try to plot 2, 1, 3. And then the second one, we'll try to plot -1, 2, 1. Okay, and we're using this new coordinate system. So I'll draw it out. Okay, label our axes. See, and okay, so 2, 1, 3. What I'm doing and what the book is doing, they kind of put an X in the XY plane where the point is, and then over top of that X, you're going to put it, go up or down, right, to get to your Z coordinates. So 2 in the positive X direction would be 1, 2, and then 1 in the positive Y direction would be right here. So, and you kind of think of yourself being right about smack dab here in the XY plane, and then you're going to go up 3. So 1, 2, 3, and I'm kind of approximating that point. Okay. Let's try the other one. Okay. And you don't have to be Rembrandt here. Clearly, I'm not Mr. Artist, so you don't have to be either. Anyways, let's try this one. So -1. This time we go backwards on the x-axis, and then 1, 2 on the y-axis. So in the xy plane, your point is about right there. And then you're going to go up 1. Okay, so our point in space would be about right there. Okay, so takes, you know, the software and the homework, you're going to have to kind of, usually what they do is give you a picture, I believe, if I can find, let's see if I can find my open student view. 11.2. Yeah, so it's multiple choice for them. So you're just, and the way they've drawn their axes is not even like me, which is kind of weird. But, you know, going out 3, right 5, and then up 6. So out 3, 1, 2, 3, right 5, and then up 6. So that one's not right. Up 3, right 5, up 6. This one kind of looks like it's right. Okay. It's probably the other one's wrong, right? So, yeah. So you don't even really have to draw it for the homework. You just have to be able to do a multiple choice. Okay, looking at distance now in space. What you end up with for your formula, which you can see there to the right, is just kind of like an augmented version of the distance that you would have in the plane, right? So in the plane, you would just have x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared square root of. Now we're just going to throw in this extra thing, and you can get your hands on that using like the Pythagorean theorem. So anyways, we have the distance formula in this new space and a midpoint formula I need to give you. So again, the distance formula, d is the square root of x2 minus x1 squared plus y2 minus y1 squared plus z2 minus z1 squared. Right? And like I said, you could pretty much use the Pythagorean theorem to get your hands on it. So here's our three-dimensional space again. And let's maybe put kind of a point here in the xy plane. And our actual point maybe is right here. And you see it kind of forms a right triangle. So this distance in the xy plane would be the square root of x2 minus x1 squared plus y2 minus y1 squared. And then this distance right here is going to be z2 minus z1. So to get the distance, let me put it in yellow, this distance right here, it's just Pythagorean theorem, right? So it's the bottom leg squared. So you would get x2 minus x1 squared plus y2 minus y1 squared, and then plus the vertical leg squared, so z2 minus z1 squared, and that would equal your hypotenuse squared. So we'll just call that d. So you have what? D squared equals, if you square root will go away, so x2 minus x1 squared plus y2 minus y1 squared plus z2 minus z1 squared. And then if you take the square root on both sides, you get that distance formula we're after. Okay, so it's just Pythagorean theorem on steroids. Let's give you the midpoint formula. So the midpoint formula is basically just averaging out the coordinates. So midpoint. So you just take the x coordinates and average them. So add them up, divide them by 2. The y coordinates. Add them up, divided by 2. And then the z coordinates. And divide by 2. Also from the distance formula, we get the, what is it, the equation of a sphere. So equation of a sphere. So it's a set of all points x, y, z such that the distance from some center point is all the same, right? So, quickly saying that, that's actually just kind of the distance formula. So I'll say my center is at x0, y0, z0, and then we could write x minus x sub 0 squared plus y minus y sub 0 squared plus z minus z sub 0 squared equals r squared. Right? So again, it's the set of all points x, y, z such that their distance from the center point x0, y0, z0 is equal to some fixed number, which is that radius. Okay. Okay. So let's look at one of the problems associated with this. So we have find the equation of a sphere. Oops. And we can make this the video quiz problem for this section. So usually I'll put video quiz. If I forget for the video quiz, just send me an email. Like in the last section, usually somebody will tell me, and I'll put the video quiz in the comments. Okay, but this will be the video quiz for this section. Let me write it down in my notes so I don't forget. It's the sphere problem. Find the equation of the sphere. Right, so what they're giving us are the endpoints, and this, so they kind of make it like a puzzle. So they give you the endpoints of the diameter. Or they'll give you like a point on the sphere or stuff like that. Diameter. So one point is 2, 0, 0, and the other point is 0, 6, 0. And first they want you to find the center. So the center is just the midpoint of that diameter. So using the midpoint formula, we have 2 plus 0, just adding the x-coordinates, divide by 2, add the y-coordinates, divide by 2, add the z-coordinates, divide by 2, and that will give us the center. Okay, so that'd be 2 over 2 is 1, 6 over 2 is 3, 0 over 2 is a 0. Okay. Secondly, then they'll want the radius. So find the radius, and that's just going to be the distance from the center to the diameter. If you'd rather, you could take 1/2 times the length of the diameter. I'll just take the distance from the center to the diameter to one of the endpoints of the diameter. So the radius will be the square root of. I'm going to start with the center. So 1 minus 2 squared plus 3 minus 0 squared plus 0 minus 0 squared. Okay. So get the square root of 1 minus 2 is -1, -1 squared is 1, 3 minus 0 is 3, 3 squared is 9. So it looks like my radius is square root 10. Okay, okay, and then finally they want the equation. And so we're just going to dump everything into our equation of a sphere from above. So I have then x minus 1 from the center squared plus y minus 3 squared plus z minus 0 is just z squared equals root 10 squared. Root 10 squared is 10. Okay. Okay, so no big deal really. Let's see if there's anything else. We have finding distance, equation of a sphere, we just did one like that. Is that it? Yeah, so now let's turn our attention to vectors in space. And it's basically the same thing as what we did with vectors in the plane, it's just we'll have one more component. Okay, so before it was ij, now we have ijk. It's pretty simple. Okay, so vectors in space, right? Okay, so part A, just our basics. Let's see if we can form a vector. So let's just call this an example. I don't know what the numbers of the problems are. So they give you an initial point. And the initial point is 3, 2, 0, and then they give you a terminal point. And the terminal point is 4, 1, 6. And first they want you to find the component form of this vector. Okay, so for A, find component form. All right, let's give it a name. We'll call it vector V. And get our square, our weird angle brackets. Right, so it's terminal minus initial, so 4 minus 3. Then 1 minus 2, and then 6 minus 0. So you just have 3 components instead of 2. It's no big deal. 1, -1, 6 is the component form. We could also put it in our standard unit vector notation, which is the IJK notation now. So standard unit vector notation. Scroll down a little bit. So that the vector I now, instead of just 1, 0, it's 1, 0, 0. The vector J, instead of 0, 1, is 0, 1, 0. And the vector K, the new guy, is going to be 0, 0, 1. Okay. All right, so to rewrite the vector in standard unit vector notation, you can literally just take the components and plop them in front of the IJK. So you can write 1I, in other words I, plus -1j, in other words minus j, and then plus 6k. And that would be the standard unit vector notation for that vector. Okay, no big deal. You'll also worry about getting the unit vector in this section as well. So the unit vector in the direction of v. Okay, so again, you're going to need the magnitude of the vector, and that will just be the components, the sum of the components squared. So 1 plus -1 squared is 1, plus 6 squared is 36. So just like before, except now you're adding in a third component, and that'll be square root 38. So the unit vector in the direction of v is going to be just the vector v times the reciprocal of the magnitude of the vector v. Okay. So we'll write that as 1 over square root 38 times 1, -1, 6. And if you'd rather, you can kind of distribute that into the vector, so you get 1 over root 38, comma, -1 over root 38. And again, I don't care if you rationalize 6 over root 38. I don't remember if the homework requires you to rationalize. Let's see if there was one in here. Nope. See, I didn't have to rationalize, so no big deal. Okay. Next thing, parallel. How do you tell if vectors are parallel? My vectors parallel. It's pretty simple. You just look at them, and if one is a multiple of the other, then they're parallel. So you could say in some sort of clever notation, U is parallel to V if and only if U is equal to a constant multiple of V. One thing to note, the zero vector is technically parallel to everything. Okay, so let's look at an example here. And so they give you a vector z is 3, 2, -5, part A. So -6, -4, 10. And usually you can just do this by inspection. You just think about what number can I multiply z by to get to this vector, right? So if I multiply it by -2, I'll get it, because this is equal to -2 times 3, 2, -5. So that works. If it gets really complicated, you can kind of set up a system and solve out for, so let's say this one you weren't sure whether it was going to be parallel or not. You could literally equate the components and just have like 3c equals 6 and solve for c. So you think maybe it's 2. Next component, 2c equals 4. So yeah, I bet it's 2, right? But then you get to the third guy, -5c is 10. And this is saying C has to be -2. So this one won't work, and it's not parallel. I think the book worries about collinearity as well. I'm not going to worry about that. You could read it, though, if you wish. Yeah, right here. So you could tell if points are collinear by kind of constructing two vectors out of the points. And if the vectors are parallel, then they're collinear. The points are collinear. So standard unit vector notation. Let's look at this force problem. I don't think there are any hard problems like this on the homework, but we'll take a look. So just one application. We have a camera sitting on a tripod, and we want to figure out the force vectors for each of the legs. So let's draw a quick kind of picture of what's going on. Really? Sometimes. Okay, so here's my camera. Sorry if it's just butchered the picture there, but okay, so this point over here, I'll call my Q1. It's located at 0, -1, 0. This point over here, I guess will be Q3, -√3/2, 1/2, and 0. And then finally this point, we'll call it Q2, √3/2, 1/2, and 0. And then this guy up here, this point is at 0, 0, 4. The camera weighs 120 pounds, so the force vector for the camera is going to be 0, 0, and then it's the force going down, the gravitational force, so -120. The force vectors for the legs, you can find the direction of the force by making vectors from the points given. So for the first leg with Q1, and I guess I'm just calling this P, Q1P, you're just forming a vector. So 0 minus 0 is 0, -1 minus 0 is -1, and then 0 minus 4 is. So that's the direction of the force vector, but you don't know its magnitude. So what you do is kind of cheat a little and just put a constant there. Okay. So you don't know what the force is yet, but you're going to be able to figure it out via kind of just the laws of force. Okay. So let's get the second force vector. Again, it's going to be some constant multiple, and because the force is going to be the same on all these guys, we could just use the same constant. So in this case, the direction by taking differences here is going to be -√3/2, -0, 1/2, -0, and then 0 minus 4. And then the force vector for the third guy, we get √3/2, comma 1/2, comma -4 again. Okay, because this system is in complete equilibrium, if you add these three force vectors together, you'll get them equal to the camera force vector. Okay, so just maybe I should rewrite it. Like if I add these three vectors together, well, actually if you add all four together, then it will just be 0, right? So let me just do that. I should get 0, 0, 0, because the camera isn't like wobbling or anything. Okay, so let's see what we get. So if I add these together, we get -4c. Oops, and I did that wrong, right? This would have to be positive. Or you could put it on the other side. So it'd be like force from the first leg plus force on the second leg plus force on the third leg is equal to the force on the camera. So sorry about that. So yeah, my first instinct was correct. Let me just, yeah. So if you add these together, then you're going to get the force vector. That's 0, 0, negative, what the heck is it, 120? Okay. So anyways, if you just add the third component, you could solve for C. Okay. Distributing the C in with all three of those as well. So you get negative 4C plus negative 4C plus negative 4C equals negative 120. And so you get negative 12C is negative 120. In other words, C is 10. And then you could get the representations of the force vectors for the legs. And that's about it for this section. 3, 5, 3. Let's see if that's what they got. Yeah. Okie dokie. As usual, hopefully that'll be good enough to get you through the homework. I thought the homework was... I'm not going to make you do this last problem. For some reason, it just wasn't working out when I did it, but I think I was off by like 1 decimal or something. But anyways, yeah, thank you for watching. Don't forget the video quiz problem in there was, what was it? It was the find the equation of the sphere problem. So basically all you have to do is write it out verbatim. That'll let me know that you're actually watching the videos and doing your job, so I don't have to worry about you. Okay, thank you for watching, and we will see you next time.